before I get going? Kind of already got going, I guess. Any, go to the order, questions or comments? Let's do this week, just quizzes, yeah? If you need templates for the quizzes, I got extra copies somewhere. I put them right here. Yep. And if you do the quizzes for this week, you're going to want to grab a couple of those. I think there are 3 quizzes up right now. 2 of them are hypothesis tests that require a template. One of them is about errors. It's basically you're exploring the spreadsheet that we did in class. So you don't need a sheet for that. You just need to answer questions on the quiz. But if you want to do the actual tests, you're going to need 2 of those bad boys right there. Please, Ryan.
Question.
Yes.
So why can't we just take x and divide it by n and then we have our answer?
Because you don't. What you have then, so this is a great question, and we're going to start dividing x bar by, well actually we're going to look at x bar today, not just x divided by n. So Veronica says, and this is a great question, I should say you're not done once you've done that. So in other words, you've got this beautiful null curve, which we're going to continue to have today. And what number is in the middle of that null curve?
0.
Always 0. Why is it 0? Yes, because it's been standardized, Danielle, thank you. Because you've standardized that number, so you've standardized it down to 0. Now that 0, contextually in the problems, has a percentage. For example, if you're doing the quiz for this week, for Thursday, there's 2 values that actually would correspond to that 0. One of them, I believe, is 75%. The Johns Hopkins quiz, I think, is 75%, and the other quiz, the CDC quiz, is 70%. So the reason I bring that up is, although 0, as Danielle correctly pointed out, is the normalized, standardized center of every curve we use, there is a contextual center as well, that, like a 0.75 or something along those lines. Now, what Veronica just said, why can't we just take your sample, as Austin pointed out, take the number of successes, divide it by the sample size, and be done? Well, because you're only halfway there, and here's why. In order to figure out where this region is, you've got to know what that z-score is, correct?
Yeah.
Now that z-score, as Emily has reminded us a number of times, thank you, gives us what? How many? Thank you. Standard deviations from 0. If you take x divided by n, this is a great comment. Thank you for that. If you just take x and divide it by n, you get what's called p hat, which we've been talking about for weeks, right? You get p hat, which is x divided by n. And what that will do is, it will put you on this line. It'll tell you what percentage your sample came up with. The problem is, that doesn't tell you how many standard deviations away you are until you normalize that. That's why you have to normalize p hat with your assumed p and then divide it by your standard error. And that brings you up to here. If you think about it from 243, we always had to use the normal, because we were always living down here with the pregnancy rates and IQ scores and Max and his Crocs and building flight seats, and there's all kinds of context. But all those contexts had to be placed back onto this curve. And that's the tool that lets us do it. So that's a great question. It's a great... Now, of course, the other answer is, why doesn't the media always do that? Because they don't, right? They'll say, oh yeah, we were expecting 75%, we got 80%. Phew, it's 5 points higher, that's huge. Maybe. It depends on how many standard deviations away from 0 it is. 5 percentage points might be 3 standard deviations. It might be a half of 1. It depends on how significant, and that's what the sample size helps measure. Thank you for that great question. It's a great question. Everybody follow? Everybody understand why we need that? Why we need to go back to this curve? And this curve is going to be with us the entire rest of the term. We got 4 more weeks together. I'll try to make it as painless as possible. But as we change tests and change distributions, it's not going to change the curve. The curve's going to be 0 is going to be our reference point pretty much from now on. And we're measuring deviation from that 0. So we have to lose the context to give it some kind of a mathematical argument. Yeah?
So this is like similar to the boxes and the overlapping kind of thing, if I'm
yes, and that's why Dai's question is so slick, is because we can tie Dai's question directly into that. It is exactly, when you land out here, you are no longer overlapping.
Yes.
Yes.
You're confident.
Yes.
Okay.
So now you're at 95% confidence and you're 95% sure, at least, that something has changed. In this case, gotten bigger, but something has changed. But it ties back to that the idea of a one-sided confidence interval, which essentially is what you're doing here, without actually generating the interval.
Gotcha.
Good. Very good questions. Really good questions. Cool. Good. this is why, yes. So there's two ways I can approach this course. I can just ram tests down your throat every day, which it's going to feel like. It might feel like that by the end, because we're going to pick them up fairly quickly. We're going to pick up a new one today, probably a new one on Thursday. But we've spent so much time developing this very first one. I mean, it's been 3 days, and I love the fact that it's been 3 days. But the fact that we're answering questions like that on the way. Those of you, who's taking more stats after this? Anybody? You're done with this. So thank God. Take more. There's some people have to take 351, 352, 467.
I don't know.
You may. That's the thing, is that when you get into those courses, they're going to go rapid fire, rapidly fast, and you're going to see some of the tests we've done in here already. So I'd rather focus on the underlying current, so if you do get into those courses, you can be like, okay, all right, that's fast, but here's the commonalities. And those of you that are done, this is going to serve you well when you ingest your research and you ingest the news, like me and the neonics. Like, sign this petition. I'm like, I'll sign it. Let me look first. Sign this petition. Sign this mortgage agreement. Sign this car deal. May I read? Maybe. You actually read those things, yes, before you sign the yes. Two of us. Okay.
Because Judge Judy will get you.
Judge Judy will get you? I tell you, you gotta watch her. See, I remember Judge Wapner. He was my judge. All right. So anyway, let's look at where we are and where we need to go. And that'll be a good place to springboard into Di's question, which I want to get to. So if you look at, let me go back one. If you look at where we just were, there you are. There you are. Hi. Make the right size so you can see everything. Oh no, you can't see anything. Sorry. Amazingly enough,